Today we'll start with measuring mass. Excuse me. What do we use to measure mass? One is
mass scale,
electronic balance. I don't think that anything is called mass scale, but it is electronic balance, or second is beam balance, also called scales. And third is, there can be too many, but we are talking about the one that can come in our syllabus. Spring balance. Now, electronic balance is the simplest of all. It is a device that has a screen on it, and then it has a panel on the top. And whatever we have to measure, we just put it here. Okay, so the mass appears on the screen. Okay. It is very easy for solids, very easy for solids, but for liquid and gases we have to do the tearing thing. Let me draw it again. For example, if we need to find volume of a liquid, we first find the sorry, what I'm saying volume, I don't know why. To find mass of a liquid, what we do is we first put the container, the empty container, on the balance, and then we put the same container containing liquid. Okay, this is,
and then we just subtract.
yes, empty container shows reading 1, and container with liquid reading 2, mass of liquid it will be reading 2 minus reading 1. So this is how we can use an electronic balance to measure mass. A beam balance or a spring balance, how do we use these two things? Now here is a beam balance. There will be a pivot. On the pivot there will be a beam. That is why it's called a beam balance. What is wrong with you? Okay. A beam is on the top. There will be a pan hanging here. A same kind of pan will be hanging on the other side. So what we do is we put the sack or something that we want to find the mass of here, and we put some known masses here. Okay. Put known masses in the pan till the beam becomes horizontal. Like like this is the unknown mass. We want to find the mass of this unknown mass. What we do is we put some known masses on the other side and wait for the beam to become balanced again. So when beam becomes balanced, it means the mass on both sides is equal. Then we add all the known masses that will be the mass of unknown object in the left pan. Okay, so this is how we can find out mass using a beam balance. This is a beam balance. Now,
Wait, sir, can you go back to the diagram for a second?
yes, there we go. The next one is measuring
Okay, thank you.
time. Measuring time commonly means measuring time interval or time taken for something to happen. Okay, when we say we have to measure time, it means we have to measure an interval of time, starting from something and ending at something. We use a stopwatch for this purpose. Actually, this is only for IGCSE syllabus that we are using stopwatch. Other things that we use to measure time is CRO, electronic timer, automated timers. There's so many things that we can use to measure time, but in our syllabus, in IGCSE, we will be doing stopwatch only. So we for something happening repeatedly, we need to measure time period. So something is happening again and again, and we need to measure its time period. How long does it take to happen once? Now, because it is happening again and again at a regular interval, instead of timing just one repetition, we will wait for the thing to happen over and over again for a longer amount of time. Long When it will repeat too many times, there will be a significant time to measure. So what we do is, instead measuring one repetition, we measure 10 or 20 repetitions. What happens? Why would we do that? If a job can be done just by measuring one, why we need to spend so much time on it? Then to
So it'll
measure,
be more accurate
yes, and why it will be more accurate? Then to
because
measure,
we took more repetitions.
so what happened?
So uh,
Time period equals to total time on stopwatch divided by number of repetition. Now, to answer the question that I asked, why would this decrease the inaccuracy in the measurement? Remember, human have reflex action delay. We see plus recognize plus decide plus execute. All this takes more time. So what happens is, we see something, we have to understand what it is, then we have to decide what to do about it, and once we decide, we have to do it. So all this takes time. So we think that we can just press the stopwatch and then press it again to measure the time, but the problem is every time we press it, we will be having a reflex action delay problem over there. We might see it and then we make some delay between actually seeing something and then pressing the button. Or sometime because of panic, we might press it before something happens or after something happens. There will always be a chance of error in this measurement. So what we do is, instead of turning off the stopwatch once, we start the stopwatch, let the many repetition happen, and then we stop the stopwatch. You would say that we still started the stopwatch and stopped the stopwatch. So that means that we still made the same errors. Now, when we measure longer time with same error, percentage error excuse me, decreases. Try to understand. For example, if we made an error of 0.2 seconds in a measurement of 2 seconds, and then we made a 0.2-second error in a measurement of 40 seconds, this will be 10%. This will be 0.5%. Although the error is still 0.2, but when we measure a longer time, percentage error decreases. So that's why instead of just timing one oscillation, we always go for too many repetitions. We time it together, and then we find the time by dividing the total time with the number of repetition that we use. Okay. Although the error stays same, but because the percentage error decreases. Now, measuring volume.
Sir, can you repeat that?
Now,
Your voice slapped out for me.
volume. Okay, what you want me to repeat? This part?
You, no, you were just saying something right now when you're scrolling the page. I couldn't hear.
Okay, I was not saying anything. I just said that measuring volume.
Okay.
I was not quite with it. So, volume of regular objects for regular objects, we only need to measure lengths using scales, vernier caliper, micrometer. So we measure lengths, and then we use the formulas, mathematical formulas, to find volume. For example, if we have a cuboid, okay, this is a cuboid, or it can be a cylinder, or it can be a sphere. So in each case, we can use a ruler to find length, width, height, and volume will be length into width into height. In this case, we can use a ruler to measure height, and then we can measure the diameter. We can half the diameter to find radius, and volume will be pi r square h. Similarly, we can use a vernier caliper to find diameter of this sphere if it is a small sphere, or we can use set squares and a ruler to find diameter if it is a large scale, and then we can find radius, which will be half of the diameter, and the volume, because it is a sphere, so volume will be O by 3 pi r cube. So these are the formulas that we need to know for volume of regular objects. Now, how do we measure volume of liquids? Volume of,
Using measuring cylinder.
yes, we use a measuring cylinder to measure volume of liquid. So here we have a measuring cylinder, say no. A measuring cylinder is a glass cylinder. It will have a broad base like this, so it can be stable, and it will have a scale on it. So this is 2.0, 4.0, 6.0, 8.0, 10.0, 12.0, 14.0, and 16.0. And remember, these readings are always in centimeter cube. And one more thing that you have to remember, not very useful for IGCSE, but 1 centimeter cube is also equal to 1 milliliter. 1 centimeter cube equals to 1 milliliter. 1,000 centimeter cube equals to 1,000 milliliter equals to
1
one
liter.
1 liter. Now, readings are always in centimeter cube or milliliters. Now, precautions while using measuring cylinder. Number one, make sure measuring cylinder is perfectly vertical when taking reading. So whenever we are taking the reading of volume, we have to make sure the measuring cylinder is perfectly vertical. To do that, place it on perfectly horizontal, perfectly horizontal bench. To make the bench perfectly horizontal, we can use bubble leveler.
Teacher, what's a bubble leveler?
It is a device that has a bubble in it. It has liquid and then it has some bubble in it. And those bubbles let you know whether something is horizontal or not. You must have seen this thing. It is a very common thing. Normally, it is at homes as well.
Oh, yeah, 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 okay. I know this, I know this.
Okay. So there is a bubble in the middle, and if that bubble is in between these two double lines, then it means that this bubble leveler is horizontal. And if it is placed on a bench, that bench is also horizontal.
Okay.
Okay. So these kind of devices are used to measure or check the horizontality of or the verticality of something. Okay, this is the first thing. Make sure the measuring cylinder is always vertical. Number two, line of sight must be perpendicular to scale at reading level. This is to avoid what? What error we avoid by keeping the line of sight perpendicular to the scale?
Parallax error.
Exactly. This is to avoid possible parallax error. So we can avoid parallax error if we keep the line of sight perpendicular to the scale. Now, third, tap the measuring cylinder gently to remove air bubbles, if any. Sometimes in liquids, air gets trapped. If you put a fizzy drink into a glass, you might see some bubbles that are connected with the walls inside the liquid. So that is carbon dioxide that is been trapped in the liquid. So some of the space is occupied by those carbon dioxide bubbles. If you need to find the volume of that fizzy drink and you put it in a measuring cylinder and you see some bubbles over there, you have to tap it gently to remove all those bubbles. In that case, all those bubbles will produce some change in the volume because they are occupying some space inside the liquid. Okay. So these are the things that we need to do to measure while using uh, a measuring cylinder. Measuring cylinder is normally used for measuring liquids, but it can also be used to measure solids, some special kinds of solids. What kind of solids? Solids that do
Irregular
not
shape.
have, yes, that do not have a regular shape, that we cannot put the formulas on, or we cannot measure them using the scale, or they are very small, or they are very um large. So in any case, they are in the shape that we cannot measure them. We can always drop them in a measuring cylinder with liquid and notice the change in the level of liquid to find the volume of that solid. Okay. Measuring cylinders are used to measure volume of irregular solids using displacement method. Step 1. Pour water in measuring cylinder and note its volume. Step 2. Drop irregular object into water and note new volume. To find volume of irregular solid, subtract subtract first reading from second, and you have volume of irregular solid. Does this make sense?
Yes, sir.
So if this is V1, this is V2, then volume of irregular solid will be V2 minus V1. Okay, tomorrow we will be starting from measuring density.
Okay, sir.
Okay, so see you tomorrow.
That's all.
Okay. Walaikum salam.